Hello good people, I'm going to continue talking about organic chemistry. Previously I mentioned that organic chemistry is the chemistry of compounds that contain carbon. And I also said that most organic compounds will have hydrogen, carbon, oxygen, nitrogen, and sometimes sulfur and phosphorus. However, it turns out that we can make quite a lot of organic compounds by using just carbon and hydrogen. And this brings us to hydrocarbons, which, as the name suggests, consist of hydrogen and carbon only. But there is more to the story. Hydrocarbons can be divided into two general groups, aliphatic and aromatic. The word aliphatic is derived from Greek, and it means ointment. A lot of aliphatic compounds were, and still are, obtained from plants and animals. And so a lot of fats, oils and waxes are in fact aliphatic compounds. The word aromatic means fragrant. So these compounds have a noticeable scent. It is not necessarily always pleasant, but it is definitely noticeable. For now, we are going to focus on the aliphatic compounds. There are three types of aliphatic compounds, and the names all sound similar. Alkanes, alkenes, and alkynes. Alkanes are compounds that contain single bonds only. We might have something like this: a carbon bonded to another carbon, bonded to another carbon, bonded to another carbon. But remember, a carbon has a valency of 4, so each carbon needs to have 4 bonds. I'm going to draw these in, and because it is a hydrocarbon, I'm going to add in the remaining hydrogens. Alkenes contain at least one carbon-carbon double bond. So now we might have something like this: carbon with a single bond to another carbon, but then a double bond to a carbon, and then a single bond to another carbon. Each carbon needs to have 4 bonds, so let me add in the remaining bonds. And because we are talking about hydrocarbons, I need to add the remaining hydrogens. Alkynes contain at least one carbon-carbon triple bond. So once again, I'm going to draw in some carbons, and now we're going to have a triple bond, and then another carbon. Each carbon needs to have 4 bonds, so I'm going to draw in the remaining bonds. And because we are talking about hydrocarbons, I'm also going to draw in the remaining hydrogens. Now, alkenes and alkynes are sometimes referred to as olefins or unsaturated hydrocarbons. I realize that I may have introduced a lot of new words. That being said, I did warn you that learning organic chemistry is like learning a new language. And just like with any language, continued use of these words will lead to proficiency. Finally, I want to spend a bit of time talking about how we get these hydrocarbons. While we can obtain quite a lot of hydrocarbons from animals and plants, for industrial use, the origin of hydrocarbons is crude oil. Crude oil is a mixture. However, it can be separated into different fractions. And to do that, we use a fractionating column. This image contains a lot of information, so let me go over it. Crude oil is piped in at the very bottom of the column. The column itself is heated, and at the very bottom we might have temperatures that are in excess of 400 degrees Celsius. These orange lines represent fractionating steps, and as we go up, each step is a little bit cooler. This means that hydrocarbons with very low boiling points will rise all the way to the top before they condense. Turns out that the boiling point of hydrocarbons is linked to the number of carbons present. The higher the number of carbons, the higher the boiling point. Or conversely, the lower the number of carbons present, the lower the boiling point. This means that we can use the boiling points to separate hydrocarbons based on the number of carbons they have. Please note that this is a very simplified drawing, and each one of these fractions can be refined further. So for example, I could take the naphtase fraction, which contains hydrocarbons that have 5 to 10 carbons, and then distill them further to separate them out. These purified hydrocarbons can then be used to make other organic compounds. Within the scope of this course, we are going to focus on hydrocarbons that are within the 1 to 10 carbon atom range. And so, if you can count all the way up to 10, you should be fine in organic chemistry. That is all for now, and I will see you on the flip side.